expanding, that's right. And we're getting that elasticity back in the balloon. Is that cool or what? Yeah. In fact, it's really, really, really cold. All right, so we've got some really neat things going. You can see that last little bit growing back out. And we have our balloon back. There we go. All right, what I'd like to do next is a series of experiments that are going to be a little bit different. So far, we've been seeing a physical change. We've gone from a solid into a gas through the process of sublimation. We've gone from a liquid into a gas through, what do you think? Through boiling or evaporation. So we have some solids and liquids. What we're going to do next is work with a gas. And instead of having a physical change, we're going to have a chemical change. So that dry ice, when it goes from the solid into the gas, it's still the same stuff. But what we're going to do is we're going to create a chemical change. Let's take a look at this right here. What is this? Periodic table of elements. Well, it's a shower curtain, but yes, it's representing the periodic table of elements. Now, we've been working with CO2 and H2O and LN2 or liquid nitrogen right here. So kind of focusing on this stuff, we're going to move it over and work with this one right here. Does anybody know what that is? Hydrogen. Whoa, very good. Hydrogen is the most abundant element in the universe as far as we know. And I've got some right here in a different balloon. We've got hydrogen inside this. Now we're going to do some experiments with this hydrogen. And I'm going to use one of my favorite things in the entire world. One of my favorite things. And that's going to be bubbles. I am a big fan of bubbles. So let's take a look. Which direction do these bubbles want to go? Up. They do want to go up. That's right. They have to be a certain size for them to go up. It has to overcome the weight of the actual bubble juice. So it goes up. So it means it's a light gas. In fact, it's numero uno on the periodic table of elements. It is number one. It's the lightest element that there is. Does anybody know of another really light gas? Yes. Helium. So where have you seen helium before? In a balloons. At what type of party? Birthday party, that's right. So those balloons stick up in the air, right? Because they're lighter than the rest of the air, so they go up. Well, we just saw that hydrogen is really light as well. So hydrogen is even lighter than helium, and it's a lot more abundant. So why don't we use hydrogen for our birthday balloons? Do you want to find out? Yeah. You want to? All right. What we're going to do is we're going to blow some hydrogen bubbles. And since I have the bag here full of hydrogen, I'm going to squeeze it. Hydrogen's going to come out, and we're going to blow hydrogen bubbles. I'm going to dip my hand into some water and then scoop up the bubbles. I'm going to scoop up the bubbles. You'll see in just a second. I'll scoop up the bubbles. All right. So what I'm going to do is scoop these up like that. And I'm going to introduce a catalyst that's going to cause a change. Let's take a look. Do you all want to see that again? Yeah! Do you want to see it with one of your teachers? Yeah! All right. So we're going to do a similar experiment, but I want you to pick your least favorite hand. That one should be just fine. Okay. So I will have you dip your hand down into there. We want a nice layer of water all over the hand. Very good. So what I will do is blow some more hydrogen bubbles. And what is your name?
My name is Miss Cockrum.
Miss Cockrum, all right. So Miss Cockrum and I are going to do a similar experiment. We're going to blow some more hydrogen bubbles. And you will scoop them up like an ice cream scoop. Is that enough? Yeah. Oh, all right, we'll go with a little bit more. There we go. go. If you go with too many, it'll actually just fly up to the ceiling. And that doesn't do us any good. So, whoa, nicely done. We're going to get rid of those pesky bottom bubbles. We don't want those. Now, I think we owe Miss Cockrum a big countdown starting with 5, 4, 3, 2, 1. So if you want, you can wipe your hand off and hang out for just a second.
Okay.
So first, let's take a look.
Okay.
Let's count. 1, 2, 3, 4, 5. We got all 5. Got rid of the 6th one. That's good. So what did it feel like?
Nothing.
Felt like nothing?
Nothing.
Really wasn't that hot at all. So let's give one more big round of applause for Miss Cochran. What we were able to do was a chemical reaction. We had hydrogen and we introduced a catalyst, which caused change, caused a chemical reaction. Now, let's think of the ingredients needed for that reaction. So, for that fire, we had to have what? Raise your hand if you know one of the ingredients you need for fire. Yes?
Bubbles?
Oh, that's a good guess. Bubbles, indeed, they're one of my favorites, but you don't have to have them for fire. What's one thing you need?
Oxygen.
Oxygen is indeed one thing you need for fire. What's another thing? You need, well, some sort of fuel. What was our fuel in this experiment? Hydrogen. Very good. So you need oxygen, you need a fuel source. What else do you need?
Heat.
You need a source of ignition. Very good. You need heat. So we had the heat from here, we had the hydrogen from the balloon, and we had oxygen from where? That's right, the outside air. Notice when we lit it on fire, it went up like this, and it had to use the air, the oxygen in the air around to continue its burn. So what we're going to do is ramp it up a little bit. We're going to increase the amount of oxygen in the reaction. We're going to see what that does. So I'm going to get a different balloon out. It is going to be our blue balloon. And we have oxygen mixed with hydrogen in here. So we're going to change the ratio and see how that affects the reaction. And first, I do believe I'm going to add something. I'm going to add some of these. Now, we've provided everybody with hearing protection here in the museum. If you just look underneath your seat, it's down attached to the end of your hands, and you just kind of do like that. So I'm going to blow some hydrogen and oxygen bubbles. Now, a part of this experiment, everybody, and I do mean everybody, will need to cover their ears. So here we go. I need everybody to please cover their ears.
Babe, what if we don't?
All right. Here is hydrogen and oxygen. So raise your hand if you'd like to share what was the difference between just hydrogen and hydrogen with oxygen. What did you observe? Let's listen closely, guys. Say that again.
Had a noise or a vibration.
Had a really loud noise or a vibration. Very good. What else did you observe?
The thingy popped.
Yeah, that's right. It popped. It wasn't a slow burn. It popped because the fuel had all the oxygen it needed right next to it. So it was mixed in there with the gas. So there's all right there. So that reaction was very quick, and it created a sound wave that hit you like a wall, and you hear that as a boom. So let's see. We've covered quite a bit of stuff here today, and I know that we've got some buses that are calling our names. So we've got a few more minutes. I want to do a couple more experiments with you guys, but first, do we have any questions so far? Yes?
Okay. Well, my main question is, how did nitrogen end up being a liquid?
Oh, that's a very involved question that I unfortunately don't have time to answer right now. But let me see if I can get with you at the end of the program, okay? So we're going to go, we experimented some with the dry ice, and I actually kind of want to go back to that a little bit, because we saw with that hydrogen and the oxygen the chemical reaction. So it expanded because it went into that plasma and it got really big and it moved the air. We heard that sound wave. I'm going to go back to that. Now, do we have, we do have fans of bubbles in here, right? We already established that? We have some fans of bubbles? Well, I'm going to make some different kind of bubbles. So instead of me squeezing it out of a balloon, we're going to make bubbles using this carbon dioxide. Using the carbon dioxide with this thing. So let's see. Let's see if we can add maybe one more piece in there. All right. Now I'm going to put the stopper on the top, and the gas will have to come out. What I wanted to show you here is we have got solid carbon dioxide down there sublimating into a gas coming out here. I really like this experiment because it shows you just how much gas is coming off of this solid. Still the same stuff. It is still CO2, but it has a lot different properties. And if you dip it into our wonderful bubble juice, guess what you get? Pretty cool, right? I'm glad, oh, it popped on the way down. That's no fun. Let's see if we can get another. I love it when they bounce on the table. Oh. So as you can see with this experiment, the gas is coming through the tube and it is blowing up the bubble. It is blowing it up. It's not me blowing it up. It's not me squeezing anything. It's the gas coming directly off of this thing. Pretty cool, right? Now I've got another type of bubble I want to show you all. It's going to be a little bit bigger of a bubble, and it will involve this right here. What I'm going to do is get a little bit more solid carbon dioxide, plunk it down in the bottom, and we need to put a bubbly lid over the top. So as that starts filling up, I'm going to put a layer of soap around the edge. So can y'all see those bubbles down at the bottom? You see the gas coming off of it? Well, we're going to use that gas to grow one large bubble. One large bubble. Here we go. Now, I'm not sure if you're aware, but bubbles are indeed a fan of hula. They like to dance a good bit. And earlier we lit the hydrogen on fire. So let's see what happens. Everybody plug your ears. It's just going to pop, guys. It's just a little bubble. Now, a cool property of CO2, of carbon dioxide, is that it is indeed a fire suppressant. So watch what happens when I put this down in there. It goes right out. That's why carbon dioxide is in a lot of fire extinguishers. It helps put out those fires. So there's different properties with different gases. Would you want to use hydrogen in a fire? No. Only if you want to make it really big. So let's see. Do y'all want to see that ghost bubble one more time? That big one? Because I'm such a fan. It is really cool looking. I'll let it grow all the way this time. I won't pop it. I will let it keep growing so that we can see what happens, what causes it to pop. But I got to tell you, I have the urge to pop it, so should I pop it?
No!
Okay, don't worry.
No!
Oh, that was slow. You guys should have been on that faster.
No!
There we go. So it's going to continue to grow as that gas sublimates from the dry ice. It's going to grow. It's increasing pressure ever so slightly, enough to cause the bubbly lid to grow and grow and grow. Eventually, the heavy gas is going to start leaning to one side, and then the bubble is going to slide down the edge of the cylinder and pop, and we'll all go, ooh. At least most likely. We'll have to wait and see. So here we are. It's growing. Actually, we have a little bit to go. I'd say another 20 seconds or so. So we've got a little bit of time. So are you having fun so far?
Yeah.
Excellent. So just to review, we have been talking about physical changes. Changes of states of matter, solids, liquids, gases. We also did a chemical reaction with hydrogen and oxygen. So we're experimenting with quite a bit of different stuff here. So we're getting close. Oh, it's getting there. It can keep growing. All right.
started to do the dancing.
Starting to do, oh, because I was probably waving my hand by it. See it moving? Oh, there it goes! There we go. You see that cloud move outward? Excellent. All right. So we have just about shown you everything, and I know you need to make it back to your town on time, but we do have just a few moments. Do we have any questions from the students? Yes, sir.
The thing that you did with the bubble in the fire to make it go like that.
So some background behind, he's asking about the bubble and the hydrogen. So hydrogen is often used in welding, and what you can do is, well, you guys can't, but in our experiment, what we did was we put a pile of hydrogen bubbles on our hand. We introduced heat as the catalyst of change. It lit on fire. Now, on my hand, and is it Ms. Cockram? And Ms. Cockram's hand, it ignited about 2 or 3 inches above our hand. And notice we had our hands flat. So that way, as the hydrogen went up, cool air came in this way, and it really wasn't very hot at all. Now, a foot above my hand, that hydrogen can burn at over 900 degrees Fahrenheit. Very roasty toasty. But our hand was nice and safe. So should you guys go home and start lighting things on fire? No. No, definitely not. But I do want you to go home and talk to your science teacher and your parent and say, I saw some awesome science and I want to find out what I can do. So there's tons of really good age-appropriate experiments. But teachers and parents, as you already know it, don't trust YouTube. Make sure and go through credible resources before you ask your students or your kids to do experiments. So that is a really good question over here. Do we have any others? Yes, in the back. The which one? You just want me to blow more stuff up, don't you? Yes. Do you want me to do it again? Yes.